Hey everyone, and welcome back. Ready for another deep dive? This one's right up your alley, especially if you're fascinated by AI like me.
Absolutely. AI is moving so fast these days, it's hard to keep up.
You're telling me. That's why we're here though, right? To break it all down.
Exactly.
So today we're looking at this really cool article about a new technique called MiniCTX. And let me tell you, this thing has the potential to totally change how AI solves super complex problems, especially in math. I'm talking about mathematical proofs.
Yeah, this is some pretty groundbreaking stuff.
Yeah, I mean, think about it. Even our most advanced AI right now, they're amazing. They write poems, compose music, even build websites.
It's really incredible what they can do.
But ask them to prove a theorem.
Yeah, that's where they tend to hit a wall.
Total brain freeze. So why is that?
Well, you see, proving a theorem, it requires this intense logical reasoning. You got to hold a ton of information in your mind all at once, make connections, see the big picture.
Right.
And that's something LLMs, large language models, haven't quite mastered yet.
So they get overwhelmed by the sheer complexity.
Pretty much.
Yeah.
That's where MiniCTX comes in, this new technique. It's like giving those LLMs a major cognitive boost.
Like a supercharged brain upgrade.
Exactly. Think of it this way. Better working memory. MiniCTX, what it does is it takes these huge complex proofs and breaks them down into smaller, more manageable chunks, like bite-sized pieces.
So instead of tackling the whole monster at once, the AI can focus on these smaller parts. Makes the reasoning process way more efficient.
That's the idea.
I like it. So it's like organizing a giant jigsaw puzzle. You wouldn't just dump all the pieces out at once.
Right, you'd separate them into sections.
Yeah, exactly. You focus on one area at a time so you don't get totally lost in the chaos.
Perfect analogy. And to build on that, MiniCTX also uses this really cool technique. It's called a sliding window. Imagine you're reading a super long, dense research paper.
Oh, I know those.
You don't try to remember every single word, right?
Definitely not.
You pick out the key points, the core arguments, and as you go, you keep those in mind while letting go of details that aren't important anymore.
It's like your brain has this mental highlighter, focusing only on the crucial stuff.
Exactly. And that's basically what this sliding window does for the LLM. It keeps the most relevant info in focus, constantly updating and shifting as it moves through the proof.
Okay, so it's like a dynamic spotlight, highlighting what's important at any given moment. But how does it decide what to keep and what to toss?
That's the beauty of the sliding window. It automatically adjusts based on the context. Old, less relevant info gets discarded, making room for the new stuff. And this constant adjustment, that's what makes MiniCTX so effective.
Okay, so that's the theory. But does it actually work in practice?
Oh, it definitely works. And we're not just talking theory here. There's solid evidence. Researchers have put MiniCTX through its paces. They use these things called theorem-proving benchmarks.
Okay, what are those?
Think of them like standardized tests for automated theorem provers.
Ah, I see.
And MiniCTX. It aced the test. It's consistently outperforming older methods, solving tougher problems faster. It's the real deal.
That's awesome. So we've gone from AI struggling with proofs to potentially changing how we do science. It's a big jump.
It is, and the implications, they go way beyond math.
What do you mean?
Well, imagine MiniCTX being used to speed up drug discovery, helping researchers analyze massive biological data sets or model molecular interactions.
Oh, wow.
Or in material science,
Ah.
imagine designing brand new materials with specific properties by solving these super complex equations.
That govern their behavior.
Yep. It could even revolutionize economics, build more accurate financial models. It's pretty mind-blowing.
It really is. It's like giving scientists this super-powered research assistant,
Exactly.
one that can crunch numbers and spot patterns that we might miss.
And this is just the tip of the iceberg. If we're seeing this now, imagine what the future holds. Could MiniCTX unlock new mathematical theorems that have baffled us for centuries?
What about breakthroughs in physics, chemistry, maybe even help us understand the universe better?
It's all possible. That's what makes this so exciting.
It really makes you wonder what other amazing things AI is capable of. We just need the right tools to unlock them. And hey, if you want to dive deeper into the technical stuff, we'll link the article in the show notes.
Definitely check it out. It's a fascinating read.
But for now, remember this. We're living in a time of incredible technological leaps. Who knows what amazing discoveries are just around the corner? Until next time, keep exploring.
Keep that curiosity alive.